Deviation is the departure from the predefined route or procedure. So there can be two kind of deviations possible. One is planned deviation and another one is unplanned deviation. So unplanned deviation is also called as the lab incidents when I talk about the laboratory unplanned deviations. Bhaskar this side, and in today's video, we are going to talk about how one can handle unplanned deviations or the incident. And this talk is going to be onto the lab centric. So let us begin the presentation now. So, what is the procedure to manage or handle the lab incidents? And sure it is. So, as a part of this, we are going to talk about five different stages. The stage number one is the moment you encountered with the lab incident, you have to report it with your reporting procedures. It can be about getting the unique identification number from quality assurance or informing to your immediate supervisor and providing the details like what was the activities under running, what samples you have prepared, etc. Once you report the incident, uh, the second step is called as the investigation because you don't want to reoccur the same incident into your lab in the future. So how you are going to mitigate or how you are going to stop this incident happening in the future? You need to understand the root cause, right? So without a root cause analysis, you will not be able to prevent it reoccurring once again. To identify the root cause, you have to start the investigation. It must be based on to available information and should follow this scientific route. For that reason, you need to have a team of subject matter expert. You can think of forming a team from different departments, for example, like quality control lab, from quality assurance, or even from the research team. So once you have the team formed, you need to conduct the investigation, and to conduct the investigation, you can use the tools like five whys analysis or Ishikawa fishbone diagram or FT analysis or failure mode and its effects analysis. So according to your preference, according to your comfort, you can select the appropriate investigation tools to conduct the investigation. Understand the purpose of investigation is to identify the root cause. Because if you do not identify the root cause, the same event can reoccur in the future also. It's also important to understand, what is the impact of the observed incident. Is there any same kind of incident occurred in the past also? What is the impact of these current observations? For example, you found that the working standard was not stored at the predefined storage conditions or the conditions which was mentioned onto the label of the working standard file. Suppose your standard should be stored at 2 to 8 degrees Celsius, but somehow it was getting stored at 25 degrees Celsius now. And if it is hygroscopic in the nature, the working standard can absorb the moisture at 25 degrees Celsius temperature. And that can result into an error in analytical result. Now this is found today, but this was stored 1 month ago now. And within this 1 month period, there must be the usage of the same working standard file for different analysis. So the scope of investigation or impact is not only for the current analysis, but you must also understand the impact of usage of such working standard file for the another analysis too. That is the impact analysis. So, and define the scope. And it is very important to define the scope very wisely. Otherwise, you may miss some very important information. Once you understand the root cause, then comes a time where you need to take the correction or suitable kappa. Correction can be very easy because this is just an action taken to come out of the existing situation. For example, if there is a usage of wrong HPLC column, so you can just replace the wrong column by the suitable HPLC column and you can continue the analysis. So this is called as a correction. But the corrective action stands for what is the action you are going to take so that the observed non-conformity will not get repeated into the future. It will never get reoccurred. How you are going to assure? What is the system that you are going to place so that the wrong column will never get used in all future analysis? That is called as the corrective action. What is preventive action? Preventive action is the action taken to eliminate the possible potential non-conformities. Now share the non-conformity is what? No peak was observed because of the usage of wrong HPLC column. The wrong HPLC column usage can lead to no peak inside the during the chromatographic run. But is that the only reason which can lead to no peak in the chromatogram? Now there are another reasons too. For example, if the analyst made wrong mobile phase, so the wrong mobile phase can also lead to no peak observed into the chromatographic run. Now this is called as the potential non-conformity. For this similar kind of problem, you need to identify what are those possible root causes which can also result into no peak during chromatographic run. And what action now you are going to take so that those root causes will not appear in your lab. Now that action is called as the preventive action, that you are not only going to stop the existing non-conformity, but you are also going to stop what are the possible non-conformities which can result into the no peak inside the entire chromatographic run. You are actually talking about the preventive action. So correction and kappa is very important for any incidences. Now once you have identified kappa, probably kappa implementation is also done. But you need to also understand, what is the trends of the incidents observed in maybe a year or in a 6 month. The trending of incident is very, very important because this will help you in understanding whether your kappas are effectively implemented or whether your team is able to identify the real root causes. The expectation is your incident number should go down as long as you are implementing the corrective actions as well as the preventive actions. So if this is reflected into your data, then you can say that I am on the right trend. That yes, my number of incidences are actually getting reduced down. Now out of this trending, it can be because between, let us say, human errors, instrumental failures and the process failures. So how these three departments functioning? Are you finding the lower incidences in human error department, whereas there is a lot of incidences happening into the instrumental department? Like there are calibration issues, there are failures during the HPLC analysis because of the instrument malfunctions. So you need to identify now what is my weak point, and you need to target that. That is the reason behind trending of the incidences. Now let us categorize the incident into two different categories. The first one is laboratory general incidents and the laboratory incidents. The purpose of categorizing is only to make the process easy for the implementation. So what is meaning of laboratory general incidents? The event or incident which are actually out of control of laboratories. So those event incidents which are not in direct control with the laboratories. Would you like to see some examples? So let me show you over here. It can be about power failure. So the power is not controlled by the lab, right? So in case if there's a power failure fluctuations occurring, it is not in the control of the lab, and you can say it is the laboratory general incidents. Sampling error, sampling is done by quality assurance. So in case if there is a sampling issues, then you can say that this is not in real control of the lab. Server issues, in case if the server is not functioning well, the lab doesn't have the direct control of the data server or the lab server. It's the IT department which control the server room. Sampling integrity issues can also be a very big problem, but which is not in direct control in the lab. Like in case if you found that the received sample, which is the finished pack in the blister with empty pockets, each blister contains 10 tablets, but out of you see that the one or two pockets are empty. Now this is the very significant error during the packaging of the drug product, and this failure needs to be investigated by the manufacturing department. You can raise an incident for sure, but you must also intimate to the quality assurance as well as the manufacturing team so that they will understand what is happening during the packaging and they will be able to take appropriate kappa over to it. Like broken tablets. So what is the reason that the tablets are broken in the sample quantity? Is that mean the broken tablets are also available inside the finished product? Or is that the tablets only got broken during the sampling? So those investigation details must be undertaken. Mismatch between pack and actual sample label. So you have got the sample inside the lab, but you found that now the actual primary pack present onto the sample talks about the different batch as compared to the batch number mentioned onto the sample pack. So this mismatch also needs to be discussed well with the quality assurance as well as manufacturing team. But if you look at all these event like power failure, sampling error, server issue, sampling integrity issues is not in direct control inside with the lab. There can be some another such examples also. So this those incidences needs to be investigated in close vicinity with the respective department. It can be with, let us say, engineering department for the power failure, sampling error for QA or manufacturing, or maybe server issues for with the IT department. Now let us talk about the core area of analytical lab, and the incidents are classified as the laboratory incidences. Now these are the events which are direct control with the lab. These are the events which are under strict control of the laboratories. Now, further, to simplify the process, I would like to categorize these lab incidences into three categories. Let us say instrument related, process related, and human related. So, what are the incidences which can be attributed? The root cause can be attributed for the instrument failure or related to the instruments or equipment. So those incidences are called as the instrument related incidences. Process related means what? Means the incidences occurred just because of the inadequate process or the procedures. So there is no SOP at all available, or SOP is available but which is not adequate in terms of giving the information. Human related means the analyst error. So the incident occurred which can be attributed to the analyst is also called as the human related incidences. So let me explain you each category with the simple examples. So let us talk about the instrument related first. For an HPLC analysis, the high baseline noise is observed due to poor lamp energy. Now this is just an example where the HPLC system was used, which found to be with the high noise, and you identified root cause for the higher noise is the poor lamp energy. Now what is the reason that your lamp has gone poor? The energy has depleted. So identify the root cause for that. Now this is the root cause, but you need to also understand the impact of the current observation, because this system was also used for analysis of the earlier batches now. Was this ignored by the analyst? This baseline of these fluctuations or the noisy baseline was ignored by the analyst earlier? If yes, you may have to repeat those analyses or few of the analysis with the good detector and understand what is the impact of those analyses. Also have the corrections and the suitable kappa in the place. The second example is for Carl Fisher titrator. We know that the KF titrator needs to be uh, calibrated, or it is not a calibration kind of thing, but you need to understand the repeatability of the result by evaluating the KF factor. So generally the KF factor is evaluated thrice and the percent RSD is measured to understand the repeatability of the measurements. And you found that the percent RSD is not within the acceptance criteria. For example, if your percent RSD requirement is not more than 2%, and today you found that, oh, percent RSD is around 3% for the triplicate measurement for the K factor determination. Now this can be because of the faulty KF titrator. So what is really wrong with the KF titrator is the part of your investigation. Now if you are investigating that, you need to also understand what is the impact of those faulty uh, spare part of the instrument. So that details will lead to understand the impact onto the earlier analysis conducted. In case if there is a really impact observed, you may have to repeat those analysis once again. Devise a suitable correction and kappa so that this event will never occur or reoccur in the future. The third example can be about the for GC analysis, no response for peak was found. You was expecting a response out of the solvent like methanol, but you prepared the standard very well and no response was noticed. Now, there could be several reasons. Maybe your detector is not working well. There is no flow of the carrier gas inside the column. So, what is the reason for no peak response during the chromatographic run? So, identify those instrument errors now and then understand the suitable correction, corrective action, and the preventive action. Let us talk about the process related incidences and share our three examples. The first one is incorrect HPLC column was used as STP did not mention specifics of the column. So you have STP in the place. STP stands for Standard Test Procedure. Your STP has mentioned use the C18 column of 250 mm, 4.5 mm and 5 micron. But whether the column from inertial has to be used, or column from phenomenics has to be used, or column from another vendor supposed to use is not clearly mentioned. The brand name of the column is completely missing from the STP. So analyst has just picked the column which is available, and analyst has picked the column which was not supposed to be picked. And he has end up with, let us say, no poor resolution. There was no resolution occurred between the interested picks. Now, the real reason is not the analytical error or analyst error. If you dig down, analyst has no guidance available on selecting the appropriate column because the STP has the deficiency. STP does not talk about the column, the suitable column or the specific column over there. And because of that, this incident has occurred. So never ever stop with the conclusion that, oh, this incident is occurred because of the human error. It's very easy to talk this way, but you will never be able to improvise onto your system. So the first rule, always keep in the mind, do not stop your investigation with the conclusion of human error. Why human have made the error is the next question you must ask during the investigation. Yes, there is a human error. The analyst has not picked the right column, but what made not to choose him or her right column? because your STP is deficient. Now, that is the real root cause. So, improvise onto your procedural part. Make the STPs with the all specific details like column name, column brand name, serial number, whatever possible that you can give, please put into the standard test procedure. And it is not only applicable about the standard test procedure, but it can also applicable to all your SOPs, all your functional documents. Those documents must provide the clear guidance so that the human will never end up meeting with the error. Unqualified analysts have conducted HPLC analysis. Now look, your lab has the HPLC systems, but there is no proper procedure in the place. Who has to use HPLC? What is the qualification need to use the HPLC? So those details are not specifically mentioned, or you do not have the process for the analyst qualification. So for that reason, analysts have started the analysis because analysts know a little bit about the HPLC analysis into his past role or the past organization. And with that gut feel, he thought that, okay, I can conduct the HPLC analysis. Understand the process part. Improvise onto your analyst qualification processes. The third example can be the poor resolution due to use of faulty new column. So you are very happy today you received a brand new column and you thought, okay, now this column must be great as it is not used so far. You watched the column, you started the analysis and end up with the accident. Okay, so you expected to have a resolution for your impurity A and API of around 2, but you found that the impurity A and API is coming as a single plug. What is wrong with the analysis? You investigated your mobile phase, preparation of the resolution solution. Everything was found perfectly all right. And you finally understand that the column is the faulty. Now you have a question that why someone used the faulty column. You have answer that we do not have any procedure to check the column's performance when you receive the column. We believe that the new column will be working very well. Now this is the procedural gap. You need to have the procedure in the place for column qualification. So identify what are the gaps available into your laboratories as far as processes or the procedures are concerned. Let me also give an example of human related incidences, and these are the three. The first one is weighing error. It is very important that as a part of common analytical technique, the dilution weighing must be imparted at the beginning of analyst qualification. You can have a training based on to the videos that look how the weighing can be take place, how to make the balance chair, how to make the boat out of the butter paper, how to transfer this sample from the container to the butter paper, how to make sure that the sample will not get lost during transferring from butter paper to the volumetric flask. Now, those details cannot be explained very well without the visual impact. So, in case if you have the videos prepared for those practices, maybe the correct way of weighing, now look this video, or what are the inappropriate ways of weighing. This is going to help analysts in understanding the right way of weighing and the wrong way of weighing. Invalid while of working standard is used during analysis. Now you have a very good practice of managing the working standard. You believe that the working standard plays a very critical role into the end analytical result, and for that you have made the working standards with the only amount of standard required for completing one or two analysis. Let us say you are crimping the vial, not working standard vial with 100 milligram or 200 milligram. Basis for this product, 100 or 200 milligram is more than enough. and you are giving a validity of only 24 hours after the vial get opened up, so that there will be no cross contamination possible, so that your working standards will never absorb the moisture once it gets open. But analyst inadvertently, you know, forgot to issue the new file, and he had the working standard file issued yesterday. So what is the impact of those uses of the one more than 24 hours old working standard file? So understand the impact and devise the appropriate correction and the kappa. The third example can be wrong instrument method selected for HPLC analysis. So analysts cannot design the HPLC instrument method, but analysts can select the HPLC method during preparation of method set in case of Empower, or during preparation of the analytical sequence. But somehow analysts have selected the wrong HPLC method or the wrong instrument method. So how you are going to make sure that when next time analysts make a sequence, analyst will never ever select the wrong method, or if he or she select the wrong method, it will be further countered or reviewed by the expert, so that the corrections can be made before starting of the analysis, and your incident will come down. So these are the examples of human related. I would like to walk you through two important points over here. The first one is, in case you identify error during the analysis, do not continue analysis to just check the result of the sample, whether the sample is passing or the failing. That should never be done. When you identify the error, you stop the analysis. If possible, correct the error with the suitable documentation by raising an incident, take the appropriate corrections, kappa, and then continue the analysis. But never ever just continue the analysis with the intention of understanding, oh, okay, I did this error. Now let me check what happens at the end result. That is not the right approach. The second point is very important. In case if observed incident leads to the out of specification result, the same shall be investigated through OOS procedure. Now there is out of what is called as the out of specification procedure, and you found that my results are really out of specification, but I know this result, this error or this out of result has occurred because of the wrong dilutions. So if I know the errors, let me take the incident and then repeat the analysis. That is not the correct way. Whenever there is a result coming up, whenever there is complete analysis done, result calculated, and if result are found out of specification, go with the OOS procedure. If the results are found to be out of trend, go with the out of trend procedure and follow that. So it is very important point. I hope now you must have got a fair idea about the lab incidences, what precautions you need to take, what is the exact steps you need to follow when you encounter with the incident. Thank you so much for watching this video, and I will meet you soon with such kind of useful and informative videos. Bye bye.